9.4 section. Now let's look at how we can find derivatives. So especially from the last section we learned to find derivative by using the concept of limit. So in that case, I know sometimes it is a very hard one because we have to calculate a lot of things. As an example, we have to calculate h of x plus h. If the function is a very big one, as an example x to the power 100 or x to the power 1000, then how we can find such expansion? So it is so hard. So today we are going to learn how we can find the derivatives by using formulas. So this one is very important. I mean, when you are day-to-day life also, if you are going to find a derivative, you have to use formulas. It is the easiest way. So now let's look at our basic preliminary formula. This is the basic step. So first we are going to learn about to find the derivative of f of x is equal to x to the power n. So you have to memorize this one. This is the important rule. If f of x is equal to x to the power n, where n is a real number, then f prime x or derivative of fx is equal to n times x n minus 1. Only thing it happen is this n come to in front of this x, you can see in here, and then you have to reduce 1 from this n. Now let's look at some example. So first you have to do this one. The u of s is equal to s to the power 8. So first you need to understand about our formula. F of x is equal to x to the power n. Then f prime is equal to n times x n minus 1. First you need to understand what is your n in here. So clearly it is 8. So now you can write in this form 8 times 8 minus 1 because it is n minus 1. So your final result is 8 times s to the power 7. So this is the first derivative of this function. Now let's go to our second function. It is given as p is equal to q to the power 2 divided by 3. Now you have to find the derivative. So what is your n? Your n is 2 divided by 3. Then you can write it as 2 divided by 3 times q to the power 2 divided by 3 minus 1. So it is 2 divided by 3 times q to the power negative 1 over 3. So this is the final answer. And you can write in this way because in 1330 course you have learned that if you take this expression into your denominator, it becomes a positive power. No need to worry so much. Now let's go to our next example. It is given as this one. C of t is equal to square root of t. So square root of t means t to the power half. So now your n is half, and you need to use the formula. It becomes n times t n minus 1. So half times t to the power half minus 1. So this is the final result. And again you can use this square root sign in here. And last one you can write, let's look at last one. It is s to the power 1 over the square root of t. So you can write it as 1 over t to the power half. So gradually it becomes t to the power negative half. So now what is your n? Your n is negative half. So you can write negative half n times t n minus 1, negative half minus 1. So it is negative half times t to the power negative 3 over 2. Then you can write it as this way and simplify like this way. So especially in here, important thing is understand your n and then set it to the formula, then calculate. Okay, now I am going to discuss about derivative of a constant. This is so important, I mean in derivatives. So you need to remember that derivative of a constant is always 0. Yes, this one. So if fx is equal to z where c is a constant, then derivative is 0. And then we are going to discuss about the functions of the type y is equal to c times u of x. Let's look at some example. In here f of x is equal to c times u of x where c is a constant and ux is a differentiable function of x. Then f prime x is equal to c times the derivative of u prime x. Look at this example. F of x is equal to 4 times x to the power 5. So understand what is your c. Your c is this 4 and your n is 5. Then constant times according to our example, our given formula. So f prime x is equal to c times u prime. So constant already have written. Then find the derivative of this x to the power 5 because we need to find u prime. 5 times x to the power 4 according to our derivative formula. So by multiplying this one, this becomes 20. 20 times x to the power 4. Now let's look at this one. Here our constant is half and we need to take derivative of this one because this is our u. So half times 2 times t, so it becomes t, and try for this one. Then I am going to discuss about derivatives of sums and differences, especially if you are given combination of functions or how we can find the derivative. So this is we call sum rule. F of x is equal to u of x plus v of x. Then we can write the derivative of f of x is equal to the derivative of u of x plus the derivative of v of x. Idea is if you are given two functions as a combination, then find the derivative separately and get the summation. For the difference rule also you can do the same process. If f of x is equal to u of x minus v of x, then the derivative of fx is equal to u of derivative of ux reduce derivative of vx. Let's look at some example, then you can understand. So find the derivatives of following functions. So this is a combination of two functions. This is your f and this is your g. So find the derivative separately. The derivative of this one, 3 times x is equal to 3 times 1 because derivative of x is 1. And the derivative of 5 is a constant and it is 0. And finally your answer is 3. So here we have to use sum rule. And now look at this one. So you can distribute it as two sections, or otherwise you can think of separately. I mean, take the derivative of this one, take the derivative of this one, and this one. So our original function is 4 times x to the power 3. So the derivative of this one is 12 times x to the power 2, and derivative of this one is equal to 4 times x, and derivative of this one is 5, and derivative of this one is 0. Then put these marks, negative, positive and negative. So finally 12 minus 4 times x plus 5. Yes, this one. So this is the derivative of first term, and this is the derivative of second term, this is the derivative of third term, and as the final term is a constant, it is 0, then you can simplify. So let's look at this example. Find all points on the graph where the tangent line is horizontal. So first, when tangent line becomes horizontal, derivative becomes 0. Then find the derivative of this one and set it equal to 0. Then you can obtain this quadratic equation. and find the factors of it. Then after factorizing, you can find 2 points. In these 2 points, this given line become horizontal. So now you need to find y coordinates by substituting these given points. So your final 2 coordinates become these. In these 2 coordinates, you can see this graph. I mean, if you draw any tangent line, it become horizontal. The reason is derivative is 0 in these 2 points. So now I am going to discuss about marginal revenue. So if you know already that we can find marginal revenue by taking the derivative of revenue function. Now look at this example. Suppose that a manufacturer of a product knows that because of the demand of this product, this revenue is given by this function. So this is the given revenue function, where x is the number of units sold and rx is in dollars. Find the marginal revenue at x is equal to 500. So by taking the derivative of the revenue function, you can find marginal revenue. So find the derivative of this one and then substitute 500, because it is asked to find marginal revenue at x is equal to 500. So by taking derivative, it becomes this value and then put this 500. So finally this becomes your answer. So if we derive this one, this becomes 1500, because this is our constant and x becomes 1 after derivative, negative, and this is your constant, so it is 0.04 times x. Then you need to substitute 500 for this function. Yes, this is the derivative, and after substituting you can obtain this. And for the second one, find the change in revenue cost by increasing this amount to this amount. So calculate the margin revenue at this point and then calculate the revenue at 501 and then take the difference. I think it is an easy one for you. Yes, here you can see it. Okay, thank you everyone, and let's meet on next day.